Recommendations for electronic circuits prototyping. Use a 30-watt soldering iron to solder your component in Vero board. Use a soldering iron and sponge with water to clean the tip of the soldering iron. Use a good quality soldering wire to wire up your prototypes. Use a proper wire wrapping wire to wire up your prototypes. Use soldering fume extractor to protect yourself from the fumes of the soldering wire. Use a good quality tin-coated Vero board for your prototyping. In our previous session, we have written a program to read the status of the 4 switches which we have connected on port D of the microcontroller, that is from port RD4 to RD7. In this session, we will write a program to read the 4 analog channels of the microcontroller, that is from analog channel 0 to analog channel 3. And now we'll modify our program to read the 4 analog channels from the microcontroller, that is analog channel 0 to analog channel 3. And here we have the command, that is ANA, and the channel number, that is from 0 to 3, and the delimiter sign, that is percentage sign. Now we'll implement this command in our program to read 4 analog channels, that is analog channel 0 to analog channel 3. And here we can check we have connected 2 variable resistors from analog channel 0 and analog channel 1. And the feedback 1 signal is coming from PWM to analog conversion circuit, which is connected on analog channel 2. And the temperature feedback from the PD100 sensor is connected on analog channel 3. We'll define a new flag here in flag assignments to read the analog channels. So here we will write, that is ANA-FLG, that is analog flag, and we will initialize the analog flag to 0 in our main program. And now we'll set the status of the analog flag in our serial read routine. We'll copy these 3 lines from our previously written program and we'll paste the lines here, and we'll modify these commands as per our new subroutine. So here we will write, that is ANA. If the first 3 characters of the receive string will be compared with the characters, that is ANA, then the value of the integer, that is test string, will be 0. And here we'll change the flag, that is analog flag. If the first 3 characters of the receive string will be compared with the characters, that is ANA, then the integer, that is test string, will be 0. In this case, analog flag will be set. Now we'll use this flag in our analog read routine. And here we will add a new subroutine, that is analog read routine. And we will write the analog read routine before main program. So here we will write, and here we will write the analog read routine, that is void and we will write the analog read routine between these 2 braces. And here we will check if the status of the analog flag will be 1. So we will write, that is if the status of the analog flag will be 1, then our program will come into this if condition. And here we will check the 4th character of the receive string to distinguish the analog channel. So here we will write, we will copy this line from the try control routine and we'll paste the line here in our analog read routine, and we will modify the command according to our new subroutine. We have studied in our previous session that how to configure the analog channels to read the analog voltages. We'll move the value, that is 02 to ADCON1 register. So here in main routine we'll initialize the ADCON1 register. So here we will write, that is ADCON1 equals to 02. Here in this prototype we are comparing the 4th character of the receive string with the number, that is 0. It means analog channel 0. If the 4th character of the receive string will be compared with 0, then the value of the integer, that is test string, will be 0. So here we will write, that is if test string equals to 0, then our program will come into this if condition. And now we'll go to the help, and in help we'll go to the micro C Profort pick libraries, and here we'll go for ADC library, and here we can find 4 prototypes for ADC read, that is ADC initialize, ADC initialize advance, ADC get sample, ADC read. So first we'll use the prototype, that is ADC initialize. So we'll copy this prototype from here and we will paste the prototype here in our main program. Now we'll go to the system libraries and we'll select the ADC library. We will go to the help again And from the sample program we can check that how to read the analog channel. So we'll copy this prototype from here and we'll paste the prototype here in our analog read routine, that is Control V, and we'll define a new variable to read the analog channel, and here we'll change the analog channel number, that is 0, and here we'll define a new variable to read the analog channel, that is unsigned integer analog read register, and we'll define two more variables to separate high byte and low byte of the analog read register. So here we will write that is unsigned character analog value low register, that is ANA low REG equals to 0, and we'll define that is unsigned character analog high value register, that is analog high register, and we'll define two more variable string to write the data on serial port. So here we will define that is analog low string and the length of the string is 3 character. So here we will write that is 3, and we'll define a new string variable, that is ANA analog high string, and the length of the string will be 3 characters. That is, now we will use these variables in our analog read routine. First we'll copy this variable from here and we will replace this variable to read the analog channel 0. ADC read prototype will return the 10-bit analog value in analog read register. Now we'll move the value of analog read register into register, that is analog low register and analog high register. And here we can see we have defined two variables, that is analog low register and analog high register. So here we will write that is analog low register equals to analog read register. So we'll copy this variable from here and we will paste the variable here, Control V. It means we have moved the low byte of the analog read register in analog low register. Now we will move the high byte of the analog read register in analog high register. So here we will write that is analog high register equals to analog read register. So we'll copy this variable from here, Control C, and we'll paste the variable here, and we will rotate the analog read register 8 times to move the higher byte of the analog read register to the lower byte. So here we will write that is rotate right 8 times the analog read register, and we have moved the value of analog read register in analog high register. Now we'll convert these two bytes, that is analog low register and analog high register, into a string. And here we can find we have defined two string variables, that is analog low string and analog high string. And here we will use a prototype, that is byte to string. So here we will write that is byte to string, and we'll copy this variable from here, Control C, and we'll paste the variable here, Control V, and we'll convert this byte, that is analog low register, in analog low string. So here we will write that is ANA low STRG, that is analog low string, and now we'll convert the byte, that is analog high register, to analog high string. So here we will write that is byte to string, and we'll copy this variable from here and we'll convert this byte into a string, that is analog high string. And now we will write the two strings, that is analog low string and analog high string, to the serial port. So we'll copy this prototype from here and we will paste the prototype here, and we will replace this variable, that is data string, with analog low string. And we'll copy this prototype from here, Control C, And we will paste this prototype one more time, Control V, and we will replace the variable that is analog low string with analog high string. Now we will go to the help, and in help we'll go for micro C Pro for PIC libraries, and we'll select UART library, and here we can find a prototype that is UART X write, and here we can find from the example that how to use this prototype, that is UART1 write data. So we'll copy this prototype from here, and we will paste the prototype here, Control V, and here we will replace this variable that is data with a constant number that is 32. We'll go to the tools and we'll select ASCII chart, and here we can find to print the space on serial port. We have to send the character that is 32 on serial port. So here we'll paste this variable that is data with a constant number that is 32. So here we'll write that is 32. It means that we want to print a space before printing the string that is analog low string, and we'll copy this prototype from here, and we'll paste the prototype here after printing the value of analog low string. So here we'll paste the prototype, that is Control V. So here we have completed our analog reroutine for the analog channel 0. But if the fourth character of the receive string will not be compared with the character that is 0, so we'll compare the fourth character of the receive string with the character that is 1 to read the analog channel 1. So we will copy this complete routine from here, that is Control C, and we will paste the routine here, Control V, and we'll change the character 0 to character 1 to read the analog channel 1, and here we will replace this ADC channel by 1. Now we'll repeat this routine 2 more times to read 2 more analog channels. So here we will write, that is Control V, and we'll replace this number by 2, and here we'll also replace this number by 2 to read the analog channel 2. And now we'll paste the routine one more time, that is Control V, and we'll replace this character that is 0 by 3, and here we'll also replace this number by 3 to read the analog channel 3. Here we have completed our ADC routine to read the 4 analog channels. Before leaving this routine, we'll clear the status of the flag, that is analog flag. So here we will write, that is analog flag equals to 0. Now we'll compile our program and we'll observe the result of our program on our RTU. And we have an error on line number 233, and here we can find we have initialized the ADC module in wrong way. So we'll delete this void from here, and now we'll compile our program once again. Okay, there is no error in our program. And now we'll send the command to read the analog channels of our RTU from the USR terminal of micro C. Now we will connect the COM port 3. Now we'll send the command to read the analog channel 0. So here we will write the command, that is AN is 0. And now we'll send the command to the RTU to read the analog channel 0. Okay, send. And here we can find we have received 2 numbers, that is 233 and 0, which is the value of analog channel 0. The value of the high byte of the analog channel 0 is 0, and the value of the lower byte of the analog channel 0 is 233. Now we'll change the voltages at analog input 0, and here we have a variable resistor which is connected on analog input 0. So we'll change the value of the analog voltages at analog input 0 with the help of this variable resistor. And now we'll send the same command to the RTU to read the analog channel 0. Okay, send. And here we can find we have received the new value from the analog channel 0. That is, the value of the higher byte of the analog channel 0 is 1, and the value of lower byte of the analog channel 0 is 36. To calculate the complete 10-bit value of the ADC channel, we'll multiply the higher byte with the number, that is 256, and we'll add the lower byte to the result. So here we are getting the number 1 in higher byte, and we are getting 36 in lower byte. Now we can calculate the complete 10-bit number of the ADC. Now we'll multiply the value of the higher byte with the number, that is 256, and we'll add the lower byte in a result. So if we'll multiply the number, that is 1 by 256, we'll get the result, that is 256, and we'll add the number, that is 36 in our result. So we'll get the number, that is 256 plus 36 It means 10-bit value of the ADC channel 0 is 292. And now we'll increase the analog voltages on analog channel 0 further. And now we'll send the command to the RTU once again to read the value of the analog channel 0. OK, send. And here we can find we have received the new value for the analog channel 0. The value of the higher byte of the ADC channel 0 is 1, and the value of the lower byte of the ADC channel 0 is 130. And we can calculate 10-bit ADC value from these two numbers, that is 256 plus 130. It means the 10-bit value of the ADC channel 0 is 386. And now we'll send the command to read the value of the analog channel 1. So here we'll replace this channel number by 1. And we'll send the command. And here we can check we have received the ADC value of analog channel 1. Now we'll change the voltages on analog channel 1. And we'll send the command to the RTU once again to read the new value of the ADC channel 1. OK, send. And here we can find we have received the new value for ADC channel 1. And now we'll send the command to read the analog channel 2. So here we'll replace this number by 2. And we'll send the command. Here we can find we have received two numbers from analog channel 2, that is 0 and 1. Now we'll send the command to read the value of analog channel 3, and here we'll replace this number by 3. OK, send. And here we can check we have received the digital converted number from the analog channel 3, that is 0 and 48. In this session we have implemented a command to read the value of the analog channel, that is from analog channel 0 to analog channel 3. And here is the command, that is ANA, and the channel number, that is from 0 to 3, and the delimiter sign, that is %sign.